Hi, and welcome to episode number 15 of the weekly Google Cloud Platform podcast. I am Francesc and Mark, and I'm here with my very, very distinguished colleague, Mark Mandel. Hey, Mark, how are you doing?
I'm good, Francesc. How are you doing today?
Very happy about actually a very nice weekend that we spent at Launch Hackathon. That's
yes, we did.
Awesome. And also very excited about the content. We're going to be talking with Varun Talwar. Sorry, I did it for this time. No, it's you. It's Varun Talwar,
Yep.
Product manager for gRPC.
Yeah, very exciting interview, and gRPC is very interesting stuff.
Yeah, I've been using it for a little bit with other projects like demos on Kubernetes and stuff like that.
Me too.
Very, very cool.
Yeah.
And after that, we're going to also be talking with Sarah Robinson again.
Yeah, we've got a really interesting question of the week talking about Firebase and mobile application development.
And since we don't know anything about it, we decided that Sarah should be back.
Yeah.
So at the end of the podcast, we'll have Sarah back to talk about Firebase on mobile phones.
Wonderful. But before we get into those things, I think we have a particularly special cool thing of the week.
Yeah, it's a thing of the week that is so cool that I almost considered editing the podcast from last week to be able to talk about it.
Yeah.
But we decided not to. But it's very exciting. It's about Spotify, of course.
Oh, yeah. What's Spotify? I've never heard of it.
Spotify, yeah, it's this little thing. They play music or something.
Yeah, something, yeah.
Yeah, they're a Swedish band. I don't know. No, they're really cool. I've actually been using Spotify for a very long time, even before they even started working with Google. And so I'm very excited that they're finally part of our customers.
Yeah.
So they actually wrote a blog post.
About how they moved their entire infrastructure over to Google Cloud Platform.
Yeah.
So they could, what is it, 75 million users?
It is pretty amazing.
That's pretty cool.
Yeah, and it's not only the fact that they moved to Google Cloud Platform, it's pretty cool, but for me the coolest part is that not only it's like they did a little bit of shift and lift, like whatever infrastructure they were already using, they moved it to the cloud, but also they started using a bunch of other Google Cloud Platform managed services.
Yeah.
Which is pretty awesome. And I have the list here.
Yeah, the ones I quite like on the big data side especially. We've talked, about with Felipe about BigQuery and stuff like that. But they were using like Hadoop, MapReduce, Hive, a bunch of homegrown stuff.
Yeah.
And they basically came across and started using all our stuff. So Google PubSub, Cloud Dataflow, BigQuery, Cloud Dataproc. So they found I can only assume better solutions within what we had for them and were managed from trying to manage their own stuff on their own end.
Yeah, and apparently they were so happy that some engineers started tweeting about it. And there's, I have this tweet from, I'm going to call him Paul Lamer, because I think he's French. And if he's not French, hey, Paul, there's an invitation for you to come to the podcast.
Yeah. Tell us literally how your name is pronounced. We'd love to hear it.
Yeah, and you can also tell us about your history. How did it go using Google Cloud Platform and so on. But there's actually one specific tweet where he tweeted, Google's BigQuery is the bomb. I can start with 2.2 billion things and compute summarized down to 20K in less than 1 minute.
Which is pretty impressive.
It is indeed pretty impressive. So we would love to have him. So if by any chance you're listening to it, or if any of our listeners knows personally Paul Lamer.
How many degrees of separation can we get from Paul Lamer?
I'm sure that someone that we know might know someone that knows him. So just let's make this happen.
Excellent.
Yeah. On top of that, they're basically using the whole cloud platform. They're also using Cloud Data Store and Cloud Bigtable, and they're also using Cloud VPN and Cloud Router and so on.
Yeah.
So it's a bunch of things. I think it's a very cool, very cool thing that we finally have someone as big as Spotify and so public, because now I can go and tell to my mom that she's definitely not technical. And she knows Spotify.
So your mom doesn't know Snapchat is pretty much what you're saying?
I don't think that. I
don't know Snapchat.
Which is probably better for her.
Yeah, Spotify's probably a better one.
Yeah.
Wonderful. Well, that sounds really cool. So why don't we have a chat with Varun? I really want to hear about gRPC.
Great. Let's go with that.
Let's do it. We are joined today by a very special man by the name of Varun Talwar. Varun is the product manager for a lovely little project called gRPC. Varun, how are you doing today?
Good. Thank you so much, Mark.
Thank you very much for having us. We really like having you here.
Yeah. So we're going to be talking about gRPC, which is a great project. I really love it because it's open source and everything is like out there and everybody can use it. Everybody's using it, actually. Lots of people using it. But before that, can you tell us a little bit about yourself?
Yeah, sure. Thank you, Francesc. So my name is Varun, as Mark said. I'm a product manager on project called gRPC. Google Remote Procedure Call, as some people like to fill it.
Wait. I heard that was not. According to the FAQ, gRPC stands for gRPC Remote Procedure Call, which is amazing.
Exactly.
Like, okay.
It's recursive.
Sorry for interrupting.
It's a recursive.
Recursive, like,
we like recursion.
Yeah. Exactly. Okay. Sorry for interrupting.
So I have actually recently taken on this role, but it is born out of something called Stubby, which Google has been using for many years. And it's awesome that we have now open sourced it, and the community can use all the great things that Google has built. So I'm super excited about the opportunities about taking gRPC to enterprise companies, to the community, and to all the new use cases of microservices, cloud, and IoT.
Cool. So we've seen that gRPC has use cases. Like one of the use cases is microservices, so it makes it perfect for nowadays. Like everybody's using microservices. But how could you describe gRPC in like 2 sentences? What is it exactly?
You can use 3. It's okay.
Oh yeah.
I mean, like,
you're
there's
allowed.
no limit.
Yeah, you're allowed.
Well, yeah. So if I had to say it in like one line, it would be gRPC is a high performance and efficient, now open source RPC framework that puts mobile and HTTP2 first. So it's really a general purpose RPC framework that anybody can use to connect to systems.
Cool.
And it supports a whole ton of languages.
Cool. So let's maybe go a little higher up. Like we say RPC. What does RPC stand for? What is that? And where do people use that?
Right. So as many of you in this audience, I suppose, would know, RPC stands for Remote Procedure Call. I'll take you back to CS 101 in our undergrad schools, which is, basically the way we were taught. All of us were taught RPCs was, you have a process, but it's not running on the same machine. It's a remote process. So how do you call it? You basically, RPC is a technology where you define what that service is. You take all the arguments from the calling machine, you serialize, you do marshalling, send them over the wire. There's an unmarshalling happens, takes the arguments, does the processing, and sends back, right? So that's how conventionally we've all been taught RPC, and that's what at the core of it is. Request response. But these days, RPC frameworks have become pretty sophisticated. They can do synchronous, asynchronous, streaming, and all those good things.
Nice. So by the description you gave, if I gave that description to anyone, I'm sure that 99% of people could say, oh, REST. What is the difference with it?
Right. So REST is pretty much become a standard in how people expose their sort of services. Used to be the SOAPs and WSDLs and sort of REST really took on with the growth of internet and sort of browsers and mobile phones interacting with internet services. Primarily because, all it was sort of HTTP methods, right? And they could flow through proxies and firewalls and easy to call, easy to test. So REST is great. This is, by no means gRPC is saying that REST is not good. REST continues to dominate, and it's great for a lot of use cases. As a lot of you know, REST is very resource-oriented. It stands for Representation State Transfer. You basically define the resources on the server side, and, HTTP get put post methods on top of each of those resources. So basically, CRUD operations on all your server-side resources is how REST works, which is great. What we have seen is when people really, really care about performance, and they care about what format is being carried on the wire, and trying to squeeze out the best performance. That is where things like gRPC shine, where we serialize into binary over the wire, as opposed to carrying JSON, when we've seen in some cases, even crazy improvements like 100x by changing that. The other thing is for a data center and cross data center large scale operations like the internet companies of the world. One, performance is critical. Second, there are a lot of use cases where it's not just request response these days. It's like with push notifications and streaming data sources and streaming data from all kinds of connected devices. People really want bi-directional streaming, both client to server and server to client. And this is where again gRPC is great, and because it allows you to establish one TCP connection and send a ton of messages on both sides, right? With having efficiency on the wire. So I think these are some of the use cases where we are seeing adoption of gRPC. The other big difference I would say is in terms of the mental model is, if I were to put it in like very, very simple terms, REST is very much nouns oriented, and gRPC is kind of verbs oriented, right? So the way you define your services is what your systems and services can do, and this is the service definition language, which is Google's implementation is based on Proto, because protobuf is what Google uses internally. But gRPC as a protocol is designed so that you can use any IDL, any interface definition language, in short IDL, and basically define your services using any IDL, and we are just the transport which will carry your messages efficiently, right?
Great. So you mentioned IDL. What does IDL stand for?
Yeah, so IDL is interface definition language. The implementation at Google for gRPC uses protobuf, which is a way you define your services. So to take it a step further, you define your methods in Proto. We give you a compiler using which which is called Proto-C. You compile using that, you get your client and server side stubs, and then you communicate at a high level.
Yeah.
That's what it is.
That sounds a little bit like Swagger, right? Like the fact that you're describing methods and resources.
Yeah. So yes, Swagger is great. It's so yes and no would be the short answer, right? So Swagger is
the easy answer.
Swagger is great in terms of its tooling around docgen testing, sharing services specification and so on, and it's greatly adopted for REST services. But we don't think of we think of Swagger as a great complementary technology that we want to actually lean in and adopt by having ways to convert some of these IDL files, proto files into Swagger, and then allowing people to use all kinds of downstream Swagger tool chains, tools that they're familiar with, so they don't have to really change the way they're using things in terms of doc generation, testing, things like API Explorer and so on.
So could that mean that at some point we might have some protocol buffer definitions and some tool to say, generate the Swagger specification that corresponds to that, and then use my Swagger Explorer to do exactly, like to go over my protocol buffer definitions?
You read my mind.
That's awesome. Is that actually coming? Can you say a little bit? Or is it something that people are working on?
Yes, it's actually being worked on. I can go a step further and say it's being used internally.
Nice.
So it's not just an idea. It's actually there.
It kind of works.
It kind of works. Yeah. So coming soon is what I can easily say. Yeah.
That's very good. I'm very excited about that.
That's awesome. Okay, so just to kind of put a bow around it a little bit. So development flow with gRPC. So we've got this IDL, we've got the definition language. So I write my protobuf file. What does that kind of look like? What is that? I know it's kind of hard to say by voice, but what sort of general concepts? How does that sort of look?
Yeah. So Proto, and if you go to grpc.io, we have great Hello World examples to actually get you started on that. But essentially, you say service, any method name. Let's say it's Hello World. You say service Hello World. you say it's an RPC input. Let's say I want to say hello Mark, so string name, and output string as well. So that's all you define, and then you say your message, which is the actual payload that will be used for the communication. So you basically define service and message. You can think of it in sort of conventional sort of terms as your methods and your sort of data schema, and you define those, and we give you a compiler to basically compile and get code generated in 10 languages.
Nice.
So it's I didn't say that wrong. It's actually 10 languages.
We're not going to ask you to say all of those.
All of them. But pretty much any language.
I'm actually wondering if I can remember off the top of my head. I want to see if I get this right. But there's C, C++, PHP, Java, Ruby,
Are you gonna...
Go.
Okay, thank you. I was like, really?
Francesc wouldn't be happy.
Python?
Objective-C.
Objective-C.
Node.
That's the wrong mistake. There we go.
So,
Yeah. Okay, so basically at the end what we're doing is what you write in the Procal buffer definition is basically like an interface, a Java interface, or a Go interface, really. Like it's just an interface with the method names and the inputs and the outputs, and then you're going to auto-generate the code for the client and the servers, and then the server is going to be like, oh, you have to actually define whatever Hello World actually does, right?
Right.
Cool. Right. Sounds good.
That sounds good. All right, cool. And then so once you've generated that code, it gives you a server that you can run in that language, and you can start it, and then you got a client that you can interact with as well.
Yeah. So you call in from client stubs, and then you test and deploy it.
Excellent. So we touched a little bit on before. You said it like you said 100 times, sort of thing. I know performance it depends, but like latency, performance. Have you seen like any sort of benchmarks or something that you've seen that sort of gives people a bit of at least a somewhat of a sense of like how fast this thing can really go? Yeah.
So performance is a tough one to answer in because
it depends.
Depends is the right answer always. It's a universally right answer for performance questions, but. We have seen, in all the, I would say 3 kinds of use cases. One is, service to services and microservices world. We have seen an example from CoreOS who is, using gRPC extensively in their distributed key value store called etcd, which is also actually one of the underpinnings in Kubernetes. And they actually put out a blog post, I think it was end of last year, December 15, where they compared it with JSON RPC. And, this is, simple put requests for etcd, which for JSON RPC was taking anything in the order of about 250 to 300 milliseconds, was then taking about 6 milliseconds.
That's it.
So you can...
It's nice.
And the blog post is out there in the public, and,
Just like 40 times faster.
Yeah.
That's decent.
Yeah.
The other example I can give is, a lot of Google Cloud services are exposing a gRPC interface as well, in addition to REST, right?
Yeah.
Some like Bigtable are only gRPC. So
which
if you
makes
look at
sense if you really care about the performance.
If you're somebody like Bigtable and PubSearch, like high performance, throughput and QPS sort of heavy systems, then those are the services which are seeing huge advantages from having a gRPC interface. The third one I would say is which. A lot of Google services themselves, including our core mobile apps, are actually in the process of switching to gRPC, which by the end of the year or so, I think we will have some real numbers around what that has been. But we are super excited with that journey and the prospects of that.
Nice. So I wanted to ask one question because I keep on getting that question over and over, and if we don't ask it now, it will be the question of the week anyway.
It'll show up, it will show
up. Which is, okay, how do you manage multiple versions of an API? Like, that's something that you have to do, and of course, one of the options is never do breaking changes. Of course. But in the real world, you will have to do them. How do you manage that with gRPC?
Right. So this is an area where Proto has actually shined and done this well within Google, as well as people who use protobuf outside would know that it sort of gives you backward compatibility. So for the if you've written protobuf files, you've seen that there's a unique sequence number attached with sort of every field. And the great thing with protobuf is that you can add new fields to your message formats without ever breaking backwards compatibility. So old binaries or services that don't know what those fields are or what they mean, simply ignore it, right? So thereby you can basically serve multiple versions of your services to different clients at the same time without without a huge cost of change or without breaking changes to existing clients, right? So with Proto, that's a great thing, right? Like people, and this happens all the time at Google. People update the protos, push them in, and the great thing is, all existing clients continue to work. Those who don't understand or don't know what to do with the new fields, just ignore them, right?
Nice.
Okay. So you could do stuff where, like, if you added a field and then somebody sent in a message and you're like, oh, that's missing, well, then I'm going to take this code down this path. But if it is there, then I will do the new thing, whatever that happens to be. And you can kind of build in your cases as you need to.
Right.
That makes sense. That makes a lot of sense. Okay, cool.
So you also mentioned that there was... We were actually trying to make gRPC something that is mobile first. And for mobile first, there's a couple of things, which is, performance is important, but also data is expensive and slow. So could you talk a little bit about that? Like, what's the difference between gRPC and other things, like maybe like just a blob, or maybe JSON, or maybe huge XML? Like, it's going to be smaller than XML, I expect.
or JSON XML, which is a standard.
Oh, yeah.
Yes.
Oh, I don't want to. I really don't want to know what that is. Yeah, so could you discuss a little bit about that?
Yeah, so from our initial, from the get-go, we wanted to have gRPC be designed in a way that puts mobile first. So there are a few answers, right? Like, one which is straightforward is, basically both JSON and XML sort of do, base 64 encoding, as opposed, so instead of that with sort of binary over the wire, that's like, that is where you get huge efficiencies and advantages from. What does it mean for mobile clients? It means less data usage. It means battery savings. Which are critical in today's times, especially if you're doing things like real-time events on your mobile apps, which are both client to server as well as server to client. This is where, again, I think bidirectional streaming from gRPC helps a lot. So in terms of actual differences with respect to JSON or XML, or JSON XML, if that exists,
we'll ignore that one.
is something we obviously depends in terms of actual difference we get. It depends on the use case. But if you go look at our documentation around protobuf, just binary serialization, I think it's 3 to 10 times smaller than XML serialization of structured data, and anywhere from 20 to 100 times faster in terms of time to process. So remember, a lot of these, it's not just about the payload size; it's also about the time to parse. Which and you remember your sort of good old days of SOAPs and WSDLs and XML parsing, and right. So that is where a lot of the development cost, not just CPU, cycles cost, used to be spent. So I think huge efficiencies to sort of gain from that.
Nice. Yeah. Seems like it'd be a really good fit for almost anywhere that, like, I mean, we tend to think in sort of web applications as well, but anywhere that needs low latency. Like, I'm thinking IoT, we sort of touched on that.
Right.
Obviously mobile as well. Gaming could potentially be another option. So there's a lot of places that could definitely fit.
Yeah, I think for mobile and, having, we we in our 10, I think we said it, which is Objective-C for iOS and Android Java. Both are something that natively are supported for gRPC. We are seeing, in fact, the first kinds of use cases we are seeing for mobile apps are all around either bidirectional streaming or chat kind of use cases.
Yeah.
Wherever payload is heavily nested and like sort of a complicated data structure and deeply nested payloads is where you'll see sort of the biggest advantages of sort of binary serialization.
Nice.
Right?
Very nice.
Very cool. So I actually have a couple more questions.
Go on.
Okay, so one of the questions is, it's actually a double-edged question, which is, okay, so why could I do this instead of just sending binary blobs? We're binary encoding, right?
Right.
So why don't I just like whatever, like in Java, serialize and just send that?
Yeah. So it's like, and each of the languages have their own such frameworks. Like Java has a good RMI library.
Oh, the nightmares.
So there's a whole lot of answers to that, but primarily being the ability to it's not just serializing on the wire, but like a standard way to specify and share services, a standard way to upgrade and run backward compatible services, and a standard way where not just how services communicate, but how services do interesting things like health checking, monitoring, tracing, stats around them. This is where one simplified approach for Google has given it a lot of benefits and has allowed it to like really do great amount of efficiency around reliability, security, operations management, analytics, which all become uniform. And suddenly, developers don't have to think, oh, how will I talk to that system, right? They don't have to think, oh, which language is that written in? I can tell you my personal story out of my, right out of college, writing a C backend, which was talked to a Java-based front end, and trying to hook JNI libraries and always crashing, and so and being very specific to how two languages communicate. So I think the if you can take that worry out and make sure it works efficiently, that's a huge plus, right?
Yeah.
And you don't have to worry about, is the Java RMI library supports this kind of serialization and supports this structure, but the one I'm talking to actually does not. So how do I?
Yeah, and I'm assuming that also versioning, like what we're talking about versioning on binary blobs, just forget it.
Right.
Not even try.
Yeah.
So you've got like this whole ecosystem around things, and then you can also sit back and be like, okay, I'm going to use the language that's the right tool for this job, and I don't have to worry about any communication at all.
Right. And any new services, that keep coming up, I write a new mobile app, I write something new for IoT devices, they just don't have to worry about how I will talk to my existing and new services.
Excellent.
Right? So.
You had two questions.
I have. Oh yeah. So my other question was, I was like, why is he looking at me now?
He was floored by the
Yeah. So there was the other question is still again about something really similar, which is what if I'm using protocol buffers? I've heard about this other thing, flat buffers. Mm-hmm. What is the difference? Why gonna use flat buffers, or can I use flat buffers with gRPC?
You can.
Actually, could you explain also what flat buffers is for our listeners?
So there are various sort of variations of protocol buffer out there. For one is actually, as Francesc mentioned, flat buffers, which is basically trying to have at a concept level, basically having data structure represented the same way in memory and in disk. So you kind of don't have to take on this conversion, serialization, and deserialization cost. Is something that is picking up. There is also another version of protocol buffers called Nano protocol buffers, which is for more for IoT kind of scenarios, making the payload even smaller and even lighter. So one great thing about gRPC in terms of its design, and kudos to all the engineers who started with the design of it, is it is designed to be IDL agnostic, right? So in theory, you can swap in an IDL of your choice. Instead of Proto, you can use flat buffers or Nano PB or Thrift or other IDLs for that matter. And it is, you can swap it out. There is some work on that, but you could, in concept, use it across IDLs. And while I'm giving kudos on design, the other thing is it's not just IDL agnostic, but transport protocol agnostic. So you could, in theory, swap in HTTP2 with Quick and get do smart things like that. Which, for those of you who don't know, Quick is an implementation on top of UDP, and some high media payload use cases like YouTube are really trying to take advantages of those.
Yeah, we had an episode with Ilya Grigorek, and he discussed HTTP2 and Quick a little bit.
Yeah, right.
That was episode.
Yes,
I don't remember.
Definitely yes.
Yeah, if, for any listener that is listening to this, just find that Ilya Grigorek HTTP2 if you want to learn more about Quick and HTTP2.
Yeah, definitely. Awesome. All right. I guess I have one more question, which is, what has been your favorite project you've seen with gRPC?
Ooh, that's a good one.
It's a very good one, clearly.
Yeah. So I'm trying to see which is a favorite one. So
and not confidential.
And not confidential. Yes. So I'll name one from yesterday, which the code I got is one of in the top up there, which was a big client of GCP was just trying PubSub over gRPC. And this is something which is, pretty much ready and ready to be released. And they were sort of our early testers. And they have basically they said, okay, we will try something like, 1 million messages per second, and just simple, publish to a topic and subscribe, sort of standard PubSub. And they currently run across huge number of servers and data centers, and they tested. And basically the developer who was testing was just like, okay, let me start on my laptop and then I'll move on to data centers. And he pretty much managed to run out of his own laptop.
Oh, wow.
And his quote was, I can serve half of my traffic just from my laptop, it seems. I mean, of course it was meant as a joke, and in terms of just, he was just trying to elude surprise by the amount of load he could just serve off his standard laptop.
Nice.
But I asked him, can I quote you on that?
It's like, return the data center. I have a laptop now.
Yeah, I'm good.
Nice.
But that just speaks to in certain use cases you just see humongous performance improvements, so that's one of my recent up there ones. Other than that, I think we are very excited about what CoreOS is doing with not just etcd, but they're using it across in their new thing called RKT, their new thing called Tectonic. So it's widely being adopted within their technology stack, we're excited to see what at Google and outside we can do with mobile use cases and IoT as well.
Wonderful.
Cool. So I think that we're pretty much out of time.
We are. So is there anything else that you would like to mention before we finish this interview?
We are... First, go to grpc.io. That's the first thing you should do after...
Okay, yeah.
Excellent. We will definitely have that in the show notes.
There's my call to action. But yeah, I mean, we are doing actually super excited to tell our listeners that we are doing our first gRPC meetup tomorrow, actually, turns out.
It'll actually be yesterday, unfortunately, by the time this comes out.
Oh,
by the time, yeah.
Let me be specific on the date. We are doing it on 3/1/6 p.m. PDT because we have a global listener base. So from the time we are recording, 24 hours from now. So excited about that. I think we are actively looking to talk to our community members, and if you're interested, please join the mailing list on gRPC-io at googlegroups.com. It's on gRPC.io. Follow us on Twitter at gRPC.io, and would love to talk more and not just get your feedback, but hopefully even get contributions.
Awesome.
Excellent.
Well, thank you so much for coming. Thank you so much for helping us understand a little bit more what gRPC is and what to use it for.
Yep.
Thank you for your time. Appreciate it.
Thank you very much. Thank you so much to Varun for joining us today. It was a pleasure and delight to speak to you. And as a big fan of gRPC, really exciting stuff.
Yeah, very, very happy that he finally came. And also looking forward to the event tomorrow, gRPC community event down in Mountain View.
It'll actually be yesterday.
That will be yesterday, indeed. And I'm very happy to see him there.
Yep.
People from CoreOS, people from Square, Kelsey Hightower from our team. So I think it's going to be a very cool event.
It's going to be a really great event.
Cool. So before we finish with this episode, we're going to go through the question of the week. And as we mentioned at the beginning, today it's going to be about how to use Firebase on mobile applications.
Yep.
And this question actually comes from one of the participants at Launch Hackathon this last weekend in San Francisco. And he basically came to our table because he was considering using Google Cloud Platform. He was not very sure. He came with a bunch of questions. And one of the questions was, okay, how do I handle authentication? I want my users to use password, email and password. And I was like, oh, you should not do that.
Yeah.
The best way to manage passwords is not managing them. So Firebase, it provides authentication with a bunch of different methods like Twitter and Facebook and stuff like that. But also provides a very nice way of doing email and password. So he used that. And then after that, of course, he put everything on Firebase because he was very happy with it, super easy. So yay. And his question was like, okay, so now I have a bunch of views and every single view needs to access that data on Firebase. What should I do? Should I create one reference and pass it around? Or should I create a bunch of references? Cause, whatever, like you can, it's easy to do. Why couldn't I do it? And my answer to him was, no idea. So to answer that question, we decided to just walk around the building and we found two awesome people that decided to help us and just come upstairs and talk to us. So we're very happy to have Sarah Robinson back. Hey, Sarah.
It's good to be back.
So Sarah, who is a developer advocate for Google Cloud Platform in our team. And also David East. Hey, David.
Thanks for having me.
Yeah, thank you for coming the whole 4 floors from the 3rd floor to the 7th floor of the office.
I actually went up 3 flights of stairs. Actually, went 4 flights of stairs, and then the door was locked, so I had to go down 1 flight of stairs and then walk across the building to the elevator, and then walk back across again. So
wow. We can get you a sandwich or something.
Yeah, it's quite intensive.
We're glad you made it.
I'm glad you got your exercise for the week.
So yeah, David is a developer advocate for the Firebase team. And I think that you had a pretty good answer to this question. Should I create references? Should I pass them around? What do I do?
Well, like a lot of people when they're first new to Firebase, they think, like, all right, when I create this Firebase class, initialize it, it's kind of like a database. So it's really resource intensive. So I want to keep it around and I want to make sure that I'm not just like creating these big objects that consume all this memory or, suck up all this data. And that's not really the case with the, Firebase reference, because when your app first connects to, your Firebase database, that creates a persistent WebSocket from your app to the Firebase servers. And when you, create another reference, it doesn't just go off and create another WebSocket. The Firebase SDK just shares on that, on the original socket built. So there's only ever one socket connected to the server. So you don't have to worry about new reference, new socket, new problems. No, it's all shares through the one. So, the Firebase SDK handles that for you.
Nice.
As far as creating them, you can, create really as many as you want. That's not going to be the memory, intensive part. The memory intensive part is actually observing, the real-time listeners for the data. And that's really only as memory intensive as how much data you're trying to sync back. Because that's, bandwidth is just bandwidth and slow internet connections are slow internet connections. So there's not too much we can do about that. But otherwise, you're totally fine with just creating a new reference inside another view controller or something like that, and just synchronizing that data to your views. You shouldn't really be using Firebase inside a view because that like messes up the sacred MVC of iOS. But but still, like, you don't have to worry about like just keeping one around.
Yeah, so it's not like when you think about server applications where you have like a database connection with pooling and it's very resource intensive and has all these connections. It's much more lightweight than that.
Yeah, exactly.
Okay. So the answer for this participant could be when you sign in, you're gonna get a UID and you create a reference rather than creating the reference and then just passing it around. Just pass the UID, which is a simple string.
Actually, it gets even easier than that. You don't actually have to pass the UID around because once you have an authenticated user in Firebase, you can actually, for iOS, you can say whatever, you create a new reference, the variable name's ref. So you say ref.authData, and as long as that user, you have a currently authenticated user, that authData property will be populated with the current user. So you can say ref.authData.uid.
Oh.
And so I actually never have to carry around any of the user information because it's always available on any reference you create.
Okay, that's pretty awesome indeed.
Yeah.
There was actually a second part of the question, which was like, okay, so I want to display a list of things. He was a list of skills, actually. And he was like, oh, so I have to go through all the JSON that I'm getting, decoding it, and then adding it to a different list so it will appear somewhere. And he was like, this is kind of like, yeah, I can do it, but it's kind of annoying that I have to write it. Is there a better way of doing this?
Yeah, there's actually a fairly new library called Firebase UI that helps you bind your Firebase data to a table view in iOS or a list view in Android. So it makes it really easy to just listen for changes whenever that data is changed in Firebase, add the new item to the list view.
Cool. So we'll add a link to those two repos. I'm assuming it's on GitHub.
Yeah, it's on GitHub. So we'll post
on the show notes.
Excellent. Well, thank you very much for coming and helping us answer these questions today.
Yeah.
No problem. Thanks for having us.
Okay, so before we finish this episode, I wanted to talk about the alternative cool thing of the week. We talked about Spotify, which is a really cool thing. I'm very excited about it. But there's also a more personal, maybe, cool thing of the week, which is actually that our podcast was launched publicly on the Google Cloud Platform blog.
Yes.
And we've got actually a lot of new listeners.
Yes. So if you're new to the podcast, welcome.
Welcome. And it's amazing because we actually created this podcast thinking about it's like maybe someone will be interested in listening to this podcast. Who knows?
Yep.
But we're actually getting listeners from everywhere in the world, which is pretty amazing.
Which is awesome.
Yeah. I wanted to mention something specific, which is the second biggest country for our listeners is Japan.
That's pretty cool.
Which is pretty amazing.
Yeah.
So yeah, if you're Japanese, hey, I'm very happy that you're actually enjoying our podcast. I really like this.
Definitely.
And send us your questions.
Yes, most definitely. In English, please, though. Actually, if you send them to us in Japanese, we do have some Japanese speakers who could translate them.
In our team, there's actually 4 people that speak Japanese.
There's 4.
Which is pretty crazy. And only one of them is Japanese.
Yeah.
So yeah, that's pretty amazing. Cool. So before we finish, where are we going to find you, Mark, next week?
So I'm not going to be anywhere special in the next couple of weeks, unfortunately. But I did just get accepted for Dev Objective, which is a web development conference in Minneapolis.
Cool.
Which is in, 14th of June.
Nice.
So that'll be good fun. I'll be there talking probably about something about Kubernetes, I expect.
Something about Kubernetes. Who knows? Yeah. Cool. I'm going to be in San Francisco next week for most of the week, and then I'm going to be on my way to Austin.
Nice.
For South by Southwest.
Very cool.
We're going to have a bunch of parties. That's going to be so much fun, though.
You're going to have a blast.
Yeah. We're going to have CloudSpin. We're going to have a bunch of talks and events and the Cloud Vision API robot and a bunch of really cool things. We have Firebase there in Austin.
Yep.
So, yeah, really great space. So if you're going to be anywhere in Austin next week for South by Southwest, come say hi. We're going to be at the Firebase most of the time. And we're going to have cool swag, cool demos, and probably drinks at some point.
Probably.
So come say hi.
Excellent.
So before we finish, I wanted to, since we didn't do it last episode,
And we have all these new listeners.
and we have all these new listeners, I think we should do this, which is how do people contact us?
Yeah, if you want to send us questions of the week or things that are cool, we definitely want to hear it.
Yep.
So people can send us emails at...
Emails. You got me there. hello@gcppodcast.com.
Yep. Twitter,
GCP Podcast.
Reddit,
It's the subreddit r/GCP Podcast
yeah, Google+,
plus GCP Podcast.
Yep.
Or you can also search Google Cloud Platform Podcast.
definitely. And on the web,
On the web, gcppodcast.com.
pretty easy.
Great. So thank you so much for this great episode. Had so much fun today.
Me too. I'll see you next week.
See you.